Hi there everyone. Hope you're all good. Let's get into O-level chemistry. Lesson 6 is metals and extraction. Metals vary in physical properties: good electrical and thermal conductivity, malleability, ductility, luster, explained by metallic bonding and delocalized electrons. Positive metal ions sit in a sea of free electrons. Those electrons can drift, which is why metals conduct, the lattice stays, the charge carriers move. Alloys are mixtures of metals, or metal with non-metal, with improved properties. Steel, iron plus carbon, is harder. Brass, copper plus zinc, resists corrosion. Aluminium alloys are light and strong for aircraft. The blast furnace extracts iron from hematite Fe2O3. Coke, carbon, burns to CO2 then CO, which reduces iron oxide at high temperature. Fe2O3 plus 3COH2 Fe plus 3CO2. Limestone, calcium carbonate, decomposes to CaO, which removes silica as slag CaSiO3. Molten iron taps off, slag floats, and is used in road building. Aluminium extraction electrolyses molten Al2O3 in cryolite at -950 degC. Large current, carbon anodes burn to CO2, environmental cost significant, but metal is light and corrosion resistant. Recycling aluminium saves -95% energy versus extraction. Reactivity determines extraction method and corrosion behavior. Iron rusts, aluminium forms protective oxide layer, gold is unreactive. Sacrificial anodes of zinc protect ships' hulls. Electroplating chromium on steel prevents rust and improves appearance. Metal uses linked to properties: copper for wiring, conductivity; aluminium for aircraft, low density; titanium for implants, corrosion resistance. Mining and processing have environmental impacts: habitat loss, energy use, CO2 emissions, balanced against societal need. Compare extraction processes in tabular form: raw material, reducing agent, energy source, products. Explain why carbon cannot reduce aluminium oxide. Link reactivity series to every industrial example. Corrosion of iron is an electrochemical process in which iron atoms lose electrons and oxygen gains them in the presence of water, acting as an electrolyte. Barrier methods block oxygen and water physically, whereas sacrificial protection relies on a more reactive metal oxidizing preferentially, keeping iron as the cathode in the local cell. Stainless steel resists rust because chromium forms a thin, adherent oxide layer that protects the underlying iron alloy. Understanding alloy design connects metallic bonding, reactivity, and materials science in a way that frequently appears in extended structured questions. Positive metal ions sit in a sea of free electrons. Those electrons can drift, which is why metals conduct, the lattice stays, the charge carriers move. Hematite is the main ore for iron extraction, bauxite is the main ore for aluminium. Knowing ore names and the extraction method expected for each metal is part of the industrial chemistry expected at O-level standard. State ore, reducing agent, key equations, and one environmental or economic factor for each extraction process. In blast furnace, CO reduces Fe2O3 at -1200 degC. Slag CaSiO3 forms from CaO plus SiO2 impurities. Do not say iron is reduced by limestone, or ignore role of cryolite in lowering melting point. Practice. Give one advantage of recycling aluminium. Answer: uses much less energy than extracting from bauxite, reduces landfill waste. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Practice. Why is cryolite used in aluminium extraction? Answer: lowers melting point of mixture, reducing energy cost and allowing electrolysis at lower temperature. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Okay, that's it for metals and extraction today. See you next time for air, water and environmental chemistry. Take care, and I'll see you in the next one.